Hello everyone, welcome back to Stardust Discovery with the Astro Princess. So today we'll be going on with the solutions of the physics past questions with the West African Certificate Examination past questions, and we are starting off with the year 2021. If you have been following up with this, you will know that we are in the second part of the theory section. And today, the question that we will be addressing has to do with dew point and specific heat capacity. I'm sure some of you already know that this all fall under the heat energy topic. So let's get into it. So the first part of the question says you should define dew point. So we'll be getting into that, but let's just take all of the first part of the question. So define dew point, explain why dew forms more quickly on the metal parts than on the rubber parts of a bicycle placed in the open overnight. I'm sure you must have experienced this yourself, but have you asked yourself why this happens? Anyway, this is more about getting your high scores in the WASSCE examination. But I think that even while you want to get high scores, it's important you understand, what you are saying, you understand the topic itself, which is part of why we are doing this video. I may not get into all that connects to that topic, but at least whatever we need to have a bit understanding that is required for the question to be answered, we will get to that. All right. So before we get into the solution, I want to remind you to subscribe to this channel. If you know anybody preparing for the certificate examination, I think you will do them a favor by linking them to this channel so that they could follow up on all the explanations that we'll be making. I find a lot of controversial solutions out there. Even the past questions don't get into the details. So it will do you good if you can follow up with how we are explaining things, especially how the examiner expects you to answer the question, because you could know the answer, you could even write what you think is right, and yet that could be different from what the examiner is expecting. So that's why this channel is important. So please like the video, comment with your questions, or even just giving us feedback. That would be very helpful. And of course, share this video with people that you know will find it useful as well. All right, so let's get into the solution. So if I were you, I could just answer this first question straight away. The dew point is the temperature at which air becomes saturated with water vapor. This is the most straightforward way to respond to that question, and you'll still get your full marks. Okay. And when it comes to definitions, explanations, it's hard to assign half a mark, quarter marks, because definitions do not change. Most times it's the same thing everywhere, which is why you need to make sure you're getting it right. Otherwise, you could lose the entire mark, because there will not be portions of marks assigned for a portion that is correct. I don't know if you get what I mean, but just to mention that. So this is okay if you want. However, you could show that you know what you're saying or what you are doing by going further to expand on this. So you could go on to include that the dew point could lead to condensation and the formation of dew. So when we get to the dew point in the atmosphere, then dew happens. So dew is the particles of water you now end up seeing. Like in the next question, we'll be looking into that. So that's the dew. But that temperature that gives you the dew is the dew point. All right. So like I was saying, you can go further to talk about other things about it, like, it represents the temperature at which the air must be cooled at constant pressure to reach the saturation needed for dew to form. Because when the air temperature drops to the dew point, what happens is that the relative humidity reaches 100%, and that is saturation. And so we use dew point as an important parameter in weather forecasting. All right. So this is if you want to go all the way, but if you notice, I'm just highlighting the very straightforward answer. All right. So let's get into the next one. Explain why dew forms more quickly on the metal parts than on the rubber parts of a bicycle plate in the open overnight. Again, I try to summarize what happens and what goes on, and you don't have to follow it word to word. You just need to understand what is going on. So there is something called thermal conductivity, which we'll also be getting into. I think that should be our next question. But so the thermal conductivity is a measure of how fast a material could, transfer heat energy from itself to another, or from one material to another. Okay, so in order to explain this, high thermal conductivity and low heat capacity. Now this is another word, heat capacity. I'm sure you must have come across heat capacity, specific heat capacity. They end up looking confusing because of all of the words, but when you try to just understand what they're talking about, in simple way, it makes sense. So just as the name goes, heat capacity of a material, right? So when a material has low heat capacity, what does it mean? When it has high heat capacity, what does it mean? If you are able to understand that, then it's easy for you to grasp the concept. So a high thermal conductivity and low heat capacity of metals compared to rubber. So usually metals will have high thermal conductivity. That's why they are used for electrical conduction. We'll be seeing in one of the videos that copper has a higher conductivity than iron. That's why you rarely see iron wire or cord. Most of the cord are made of copper because they have high thermal conductivity. So is a better material for electrical conduction as well. Okay, so back to what we are talking about. Because of this high thermal conductivity of metals and in connection with their low heat capacity compared to rubber materials, metals can easily transfer heat. I'm sure you know this. We are now talking about the physics or the science behind what you already know. So you notice that metals can transfer heat. You put a metal into a hot plate or something to heat it up, it will catch the heat fast. That's because of the high thermal conductivity. All right. Now, during the night, when the surroundings cool down, usually you notice that the night times have much cooler temperature. That's a different topic, not for today, but anyway, usually this happens. So metal parts lose heat. So cooling temperature means is losing heat, right? You are losing temperature, so you lose heat as a result. So thermal parts will lose their own heat faster. Everything is losing heat once it's evening. Normally, everything is losing heat because the sun is away, remember? So, but then metal parts will lose this heat faster. And as a result, the temperature of these metal surfaces will drop below the dew point faster. So what that causes is that the water vapor in the air will now condense on the metal surfaces and then form the dew. All right, I hope that makes sense, but I will be moving on. So just try to understand what goes on. It will help you to answer this type of question, because all you need to do here is to explain, and you just use your terms, and if possible, mention the key things. Like this thermal conductivity is one of the terms an examiner will be looking out for. Even if you don't mention the heat capacity, because it's almost like they are related. The high thermal conductivity is related to heat capacity. It's just an inverse relationship, so you just need to mention one of it and it's fine. And then every other thing, you can use your words to make your points clear and passed down. All right. Okay. Again, depending on the year, the marks to this would vary. I'm not going to be focusing a lot on marks. I have mentioned that for explanations, you need to get it right, and definitions, you don't want to get some correct and some wrong. All right, so there is another question, part B, part of that question 9, and it says, explain the statement, the specific heat capacity of copper is 400 joule per kg per Kelvin. Per kg is same as per kilogram. Okay, so explain that statement. We've talked about specific heat capacity briefly. Now, if you're asked to define specific heat capacity, what would you say? Now, if you know what you would say, this question is now giving you a value to that parameter, and is expecting you to just explain the same thing, but in the context of the value. That's what this question is about. So normally the specific heat capacity generally is the amount of heat energy required to raise a material that is 1 kg. So 1 kg of that material raising its temperature by 1 Kelvin. So the total heat energy required to raise the temperature of 1 kg of a material by 1 Kelvin. That's the general definition. Now, you want to be specific here because the question is specific. He's now talking about that of copper and is giving you a value. So you just repeat the same thing, but instead you customize it for copper. So that's what you should do here. So it means that it takes copper 400 joules per Kelvin, 400 joules. This time we are trying to define specific heat capacity of copper, right? It takes 400 joules of energy for copper for you to raise its temperature by 1 Kelvin. So what that means is that if you are given 1 kg of copper, you will need 400 joules of heat energy to increase the temperature of that 1 kg of copper by 1 Kelvin. So if it was at 2 Kelvin, when you apply 400 joules of energy, that copper that is 1 kg of mass will have a temperature of 3 Kelvin after applying the 400 joules of energy. That's what it means. And this is an enormous amount of energy if you think about it. But that's what this question is asking you to do. Again, this is a definition related question, so you need to make sure you get it fully correct. All right, so the next question, which is asking two metals P and Q are supplied with the same quantity of heat. If the ratio of the specific heat capacity of P to Q is 3:1 and their masses are in the ratio 1:2 respectively, calculate the ratio of the temperature rise of P to Q. Now, this question is talking about two metals named P and Q. They were supplied the same amount of energy. Now, you need to pay attention to that because when you are solving this question, you could use that information. So, same amount of energy or heat applied to the same two of these metals, and we have been given their specific heat capacity in form of ratios as well as their mass. So in order to answer that question, we need to first of all remind ourselves what the formula required to calculate heat energy in general. Now, how do you know what question is related to? So one way that I usually advise is that you first of all understand the topic that the question is referring to just by looking at the words. So there are some words mentioned here like specific heat capacity. They talked about heat, talked about temperature rise, talked about mass. Those are pointers. Those are pointers to the topic required. Okay, so those would help you streamline the formulas that are likely needed to solve the equation, because I understand that sometimes you could have similar, formula for different type of things. So that's one way to, know what you should be looking at. Another point will be the given parameters. So looking at the parameters given, in this case, you are given the specific heat capacity, even though it's in form of ratios, but you are also given mass. So, and somehow they give you energy because they said they are of the same energy, so they are equal. They are going to have equal heat energy. So you do have some information there. So now think of the equation that connects these three things. So if you are given parameters, you should think about equation that connects the parameters together. That's the second way, which seems more like gambling. So what formula connects mass and specific heat capacity, energy, temperature? So like just thinking of that, you end up getting to heat energy equation, which is mass times specific heat capacity times change in temperature. So that is what we need. Okay, so like I mentioned, we have been told that they have the same heat energy. Therefore, we are going to equate the two. So let's have equation 1 being the equation of heat energy for that metal P equal to the equation of heat energy for metal Q. Now we are establishing our equations and the given parameters. You are also given the specific heat capacity, which is designated as C, small c here. So that of P will be 3. Remember, this is ratio. And that of Q will be 1. For masses, the mass of the metals you have for P1 and for Q2. So with this in mind, you are off for a good start. So you can substitute this information from equation 2 into equation 1. And that gives you this equation: 1 times 3 times change of theta for P equal to 2 times 1 times change of theta for Q. So when you get to this point, remember that the equation here is that you should find the ratio of the temperature rise of P. Now you want to make sure that you do not misinterpret temperature rise to mean maybe one of the temperatures. So when you are looking at this topic, you will come across different types of temperatures. There is theta 1, theta 2, which could mean initial temperature, final temperature. And for you to find heat difference, change of temperature or temperature difference, you have to subtract between the two, and that's what gives you change in theta, where theta is the temperature. So whenever you see temperature decrease or increase in temperature or temperature rise, that means theta 2 have been subtracted from theta 1, or theta 1 have been subtracted from theta 2. They have done that process to now give you a value, or the process, the value or resultant of the process is what you are asked to find. Like in this case, you are asked to find the resultant of doing theta 2 minus theta 1, and that is the change in temperature. In this case, they were specific to call it a temperature rise, because temperature decline could also be a change in temperature. Whether it's decline or rise, or decrease in temperature or increase, they are all change in temperature. So here they were specific, they said the temperature rise. So also be careful about the way the ratio should go. So this question said the ratio of P to Q. That means you need to rearrange this equation. At this point, you do not have any other variable except the temperature rise for the two metals. So just rearranging that so that it will answer the equation. So let P be the numerator and Q be the denominator, and that should give you 2/3 or 2:3. So do not make the mistake of doing 3/2, because that is a common mistake in this type of question. So you need to pay attention to the ratios so that you don't mix them up. Okay, and there you have it. That should be the answer to your question. So I will just give you a rundown and get the equation that is required, make sure it's correct, look at the given parameters from the equations given, and come up with the values that you need. Actually, that's also how you come up with the formula to use, but also come up with the values for each of the parameters. Think about where they fit in the equation or in the formula, and substitute. And when you do that, solve until you can no longer solve, and begin to ask yourself, go back, keep going back to the equation until you figure out the next step. So yeah, I hope that was clear. I will continue in this question in our next video. I hope you stay tuned, and feel free to ask your question using the comment section, and or maybe reach out to me personally if you want. And yeah, there you have it. Like I mentioned the other time, if you are not sharing this video to people that you really love, that are also going through the certificate examination, then how exactly are you their friend? All right, so please connect, subscribe to Discovery Status, comment, like, and share the video. And I'd like to leave you with this word, focusing on where you are right now, and taking all the lesson, all that life has got just for this season. It gives you contentment even in the midst of adversity. So I know that young people will have the tendency to want to get to the next phase, the future, so quickly. But sometimes the present situation or the present season is preparing you for that phase. And so when you rush it, you could be missing out on some incredible things and lessons you need for where you are headed. So yeah, take your time, and I will see you in our next one. Bye.